All good? So, thanks everyone for coming tonight. So we're going to talk about Angular, and as you can see, we're in Sydney, according to my slides. And that's because I did this talk last Friday in Australia. So I flew back on Sunday, caught another flight yesterday night to get to Salt Lake City, and here I am. I live in Sacramento, California, so, you know, that's a long way to get here. So I didn't change my slide, sorry about that. It still says NDC Sydney, but you get that in Salt Lake City, so you don't have to go see kangaroos to learn Angular. I didn't see any, by the way, so. So we're going to talk about Angular Cypress as well. So before I get started, I just want to start with this because the Angular team, they don't want us to say Angular 8 or Angular 9 or Angular 6. They want us to say it's just Angular. So a couple of years ago, they created a Twitter account to just show us that it's just Angular. So just a reminder, Angular 1x means AngularJS, the old version of Angular, and Angular 2+, we just call it Angular. So from now on, it's going to be an introduction to Angular, right? So who doesn't know anything at all about Angular in this room? Oh, that's great. That's the majority. I like that. Because then it's really exciting. So who has a little bit of exposure to Angular, kind of knows a little bit how it works and all that? Okay. And who knows a little bit more about Angular but just wants to dive deeper? Okay, perfect. So, what's Angular? Well, before I get started with Angular, a little bit about myself. So my name is Alain, or just Al. I'm a Google developer expert in web technologies, more specifically Angular, as well as Google Maps. I started a long time ago as a Java developer, 2006, and then I got into AngularJS in 2011. And I've been doing a lot of consulting and training around Angular since then. So my website is angulartraining.com. That's the reason why I'm in Salt Lake right now. I'm teaching Angular today and tomorrow. So I've been going through most of these slides from 9 to 5 today. And I didn't get enough, so I'm doing it again tonight. And I'm doing it again tomorrow. So my life is all about Angular. So I live in Sacramento, California, where I organize the Angular meetup group, of course, as well as Google Developer Group Sacramento. So these are two meetups, just like this one, where we meet once a month and talk about all things Angular for the Angular meetup and Google Technologies for the GTG group. So I already asked those questions. So let's get into Angular. So you're probably familiar with PHP, ESP, JSP, all of these P languages that have been around since forever, almost. And that's still how 60% of the web works today. So 60% of the internet still uses one of these technologies, where the idea is you navigate to a web page, sending a request to a backend. The backend is getting to a database and then building some HTML, returning it to the client. And then you click on a button and boom, the same thing happens. Send a request, build the page, return it to the front end. So this works. I mean, the internet is still mostly like this, but there's a few ways in which it's not efficient at all, because, well, every time you do something, we're making a round trip to the server and just downloading a new web page, which most likely is going to be very similar to the previous one, right? We're going to have the same menu, the same header, the same kind of stuff, and just some content is going to be different. And the other thing with this is, if you have 1 million people on your website, then your server ends up building 1 million times the same pages over and over again. So it doesn't make a lot of sense. But still, it's how the web started to become dynamic. And it was the first step towards what we have right now. Then, so things evolved a little bit. 2004, 5, 6, Ajax became more and more popular. So things like Facebook, Twitter, they needed dynamic content. They needed websites that are just, you know, always notifying you, oh, there's new stuff, oh, check this out, oh, there's some changes, oh, come here, there's new messages and new things. So Ajax made this very popular. And with Ajax, the idea is you would make an HTTP request in the background to the backend to fetch some content and just update some portions of your user interface. So that was Ajax. But now it was even more complicated when we got there, because now you have PHP or JSP or ASP generated some part of your page. And then you have JavaScript in the client side also getting some data to do some other things with that page. So you have business logic all over the place, and it's difficult to maintain, and it's difficult. So with all of that in mind, someone decided that it was enough, and that the UI should be generated on the client side. So AngularJS was born. It was really the first framework that was bold enough to say the UI belongs in the browser, not on the client side. So that was the idea from the very start of AngularJS, was that all things HTML, CSS, JavaScript, that should just run in the browser and not be generated by the backend. So that was a big switch in terms of how we see things and how we think about web apps, right? Because before that, it was all server-side, and now we're thinking, oh, okay, it's going to be mostly client-side, and our server becomes a web service that's going to give us data to display. So when you switch to that mindset, you can have a team of developers working on the front end, focused on HTML, JavaScript, CSS, and a team of guys very good on the back end, focusing on making the queries efficient on the database, optimizing things so that accessing data is fast, and all of that. So all of these different responsibilities are easier to manage when you switch to that mode, because it's two different code bases, basically. You have Angular, JavaScript, HTML on one side, and the server side, which can be anything. So it could be Java, .NET, anything you want, to just get the data. So clear separation of concerns between user interface and backend. So that's how we got into AngularJS, and that was 2011. So that was AngularJS or Angular 1. It's been around for a while. It's still very much alive. I've seen many people use AngularJS. Many different projects are based on AngularJS because it's been around for 7+ years, and it's been very, very popular. Now the thing is, the web is always changing, and as AngularJS evolved, the browsers became faster and better with JavaScript. JavaScript evolved as well, and a lot of things changed so that it kind of became, at first it was a crazy idea to do everything in the browser, and now it became mainstream, where we actually do more and more in the browser, more than ever before. So in order to support that idea even further, the Angular team said, we're going to rewrite Angular. That will be version 2 and 2+. So it's going to be a brand new version of the framework, released at the end of 2016. And now this one is, they do a +1 of the major version number every 6 months. So 2, 4, 5, 6, 7, 8, and 9 is happening within the next few weeks. And then 6 months later, we're going to get Angular 10, 6 months later, Angular 11. So the screen. So it might seem a little bit surprising that just 3 years ago it was Angular 1.5 and now it's Angular 8, or even Angular 9 very, very soon. Come on, come back. Not move at all. It's probably good on that. It's my laptop. So this puts a little bit of weight and. Oh, it's pick it up for a second. So I'm not saying anything anymore. I'm going to get away from this. So Angular 9 is coming very soon, and
Still JavaScript?
So it's not JavaScript anymore. The main language for Angular is now TypeScript. And we're going to get into that and see what it brings to the table. So yeah, what seems a little bit scary is that we had Angular 1 for 6-7 years, and now we're already at Angular 8 within just 3 years. So people might think, well, that's crazy, they're just changing everything all the time and rewriting everything. That's not the case. The difference between Angular 8 and Angular 2 is not much. I could probably cover all of the changes between 2 and 8 in just 20 minutes. It's just, incremental improvements, work that they've done on improving the compiler, making things faster, more efficient, all of that. But in terms of the code you write, it didn't change that much between Angular 2 and 8. Whereas the jump from 1 to 2, you had to rewrite everything because it was a completely different framework.
So yeah. There's not a lot of changes between individual releases. Why are they incrementing the prefix number? Normally, small changes you increment stuff.
So I'm not showing the full picture here. It's actually much more dynamic than this. The reason why I show the 6 months is because that's the only time when they can bring breaking changes to the framework. So changes that would require you to update your code so that you can use the latest version. But Angular itself these days is updated once a week. So I'm going to go to the Angular code repo. So it's all open source, maintained by Google. You can just access the code from here, and I go to the releases, and you'll see that the last version was 2 hours ago. So version 9, 2 hours ago, so that's a temporary beta version. And 8.2.12, 3 hours ago, so today. And I'm not surprised, because every time I teach Angular, they just release a new version as I speak. So, and you'll see it's very consistent. So these minor versions, so 12, 11, 10, it's once a week. So 8 days, 14 days, 21 days. So that's bug fixes, very minor fixes, security improvements, that kind of stuff. The minor version, so the one in between, the 0.2 in 8.2.10, this one increases once a month maximum. So when they have new features that are interesting to release and they don't have any breaking change, they just do a +1 on this minor number and release it once a month. And then every 6 months we get the +1 on the major version, so 8 to 9, and this is going to happen very, very soon. So it's extremely dynamic. You can see that within the last month we had 3, 6, 9, 10 different releases in just 28 days. So yeah, it's a crazy rhythm. I don't know how to do that. Well, the thing is, Angular is very widely used at Google. So right now they have over 1,500 different projects built with Angular at Google alone. And some of these projects are part of YouTube or Google Analytics or things that are used by millions, if not billions, of people on a daily basis. So that's how robust it is, and that's how they use it very intensively. And yeah, 2 years ago they had only 800 projects. So just in 2 years they doubled how much code they have using Angular at Google alone. You can see many more examples at madewithangular.com, where you see all of the different websites that are built with it. Most of the time it's big enterprise projects. So you'll see banks, you'll see financial corporations, you'll see governments, you'll see airlines a lot too. So Delta, VMware, BMW, government in Australia, University of Utah. So yeah, it's all over. So as I mentioned earlier, Angular is made with TypeScript. And that was, what was a revolution when they did that 3 years ago? They were the first, Angular was the first framework to bet on TypeScript. So what is TypeScript? TypeScript is a superset of JavaScript. So in this bubble here we have ES5. So ES5 is JavaScript from 2004. So it's the old version of JavaScript, and this one is very well supported by all browsers. Even IE 10 supports like 99% of ES5, so that's pretty good. ES6, that's from 2015, so that's more recent, and no browser is at 100% of support of ES6 yet. Even Chrome, Safari, Firefox they only do 97, 98% of ES6. So that's not good because you have two different versions of JavaScript, and it's a premise that's always been there. You write something, it works in one browser, it doesn't work in another, and we don't want to be doing that anymore. So TypeScript is the solution. Because what happens when you use TypeScript is that you can use any feature from ES5 or ES6 or even more, because TypeScript has its own set of features, such as types and decorators, annotations, and more. And that TypeScript code, while there's a compiler, that turns it into ES5. So it's like magic. You can use all of the latest stuff from all of these languages, and in the end it works in all browsers, because this compiler does the work of just translating the code into something that works everywhere. So that's a good idea. And that idea came from Microsoft, actually, which is interesting, because Angular, which is backed by Google, is using TypeScript, which is backed by Microsoft, to make things happen. But it kind of makes sense that TypeScript, well, Microsoft would work on a language that makes things work with IE. So instead of fixing IE, they try to fix the language so that it works with IE. I guess that was the plan. So that's the thing about TypeScript. The main purpose was that you can write anything. Don't worry about browser compatibility, because the compiler does that for you. But there's another huge benefit to TypeScript, and I'm going to show that to you right now. It's that TypeScript code actually looks very much like things that most people are familiar with, because it's object-oriented, it's using classes, it's using types. So if I open some TypeScript code, you'll see that it looks like this. So we have a class, I have a property in that class, and it has a type, string, and there's a decorator applied to it. So if you're familiar with Java or C# or .NET, it's like, oh, it's similar. I know classes, I know types, I know decorators, and it feels very, very familiar. And because of that, because you get type safety, because you get object-oriented features, TypeScript and Angular are a very good option for enterprise projects where you have hundreds of developers working on that code. It's just easier if you have types and a nice structure to know how things are being built. So these are the two main reasons why TypeScript is a hit, and that Angular bets on TypeScript from the very start. And now the other front-end frameworks, such as React and Vue, since they saw that TypeScript works very well with Angular, they are now promoting TypeScript with React and TypeScript with Vue, just because, well, you can do that too. It's just a compiler that turns code into ES5 JavaScript. So that's TypeScript. Any questions on that? Sounds too good to be true? It actually works. It actually works very well. Yeah. So now I'm going to get into Angular itself, but before I do, I have to talk about Angular CLI. So Angular CLI, CLI stands for Command Line Interface. So that's a command line tool that you can use to do everything with Angular, including compiling our project. So I'm going to illustrate that right now. Let's clear my terminal. So this is an Angular project that I have on my machine. I'm going to use Angular CLI, which is always ng command. So Angular CLI is ng. And here I'm going to do ng serve, which is going to go through all of my project, compile all of the code, start a web server on my machine, and then serve that project on my machine. So it does everything at once with one command. So now it's doing it, it's going through all of my TypeScript code compiling to JavaScript. So it's doing it, optimizing things a little bit. And then it's going to be started. There we go. So now it's up and running. This project is compiled. If I go to my browser and navigate to localhost 4200, that's what it looks like. So it's a basic store with some products in it, and that's an Angular application. The nice thing about it is that now that my ng-serve is running here, it's watching for my file constantly. So if I go and change my code and just save my changes, this is going to see, oh, you changed the code, I'm just going to recompile the small portion that you changed, and then push that to the browser and refresh the browser. So when you go back to your browser, the change is already there. And I can show that to you right away. So this says, welcome to our store. Let's change it. So this text comes from here. Let's say I'm going to have 3 exclamation marks. I just save that change, go to my browser, walk away from my laptop, and it refreshes automatically, and I have my 3 exclamation marks right there. So that's ng-serve. So now I just keep it running in the background, and it's going to see my changes and just do everything, which is nice. So you can use that Angular CLI for everything. You can use it to generate some new code. You can use it to run your unit tests. You can use it to build your code for production. No, I didn't do anything. Okay, it's back. It does all of that. So whenever you want to build for production, you can do ng-build prod, and it creates a build for production, where your code is all optimized, minified, obfuscated, all set to be deployed to prod. So now I'm going to talk about components, because components are the most important thing to know about Angular. So what a component is, it's really our own custom HTML element. When you create a component with Angular, you're creating your own HTML element. So if you know HTML a little bit, you're familiar with div and a and all of these different tags that we have. When I create a component, I create my own tag. I give it the name I want, and it's going to be in charge of a small portion of my screen. That's what a component is all about. So if I go to that store here, we have quite a few components, and I can show them to you by diving into the code here. Make this a little bit bigger. So that's my HTML page. It has a body, and inside the body we have app root. So that's one component. That's the main component for my Angular app. And then I have app navigation. So that's the navigation bar at the top up here. This is my app navigation component. Come on. There we go. Then we have a main section where we have Jumbotron. So Jumbotron is this gray area with the text and everything. And finally, we have a bunch of license plates that are displayed. And these are individual components. So that's one license plate component. That's another license plate component. So you can see that these are HTML elements that show up in my HTML, even though they don't exist in the HTML language themselves, right? So we extend the language by providing our own tags. And then when we want to use them on the screen, we just use them like regular HTML, and things show up, which is really nice. So what does a component look like in terms of code? If I want to create a very basic component, so this would be a hello world component. So it's going to have a TypeScript class, as you can see here. That's the hello component class. It has one property name of type string. In the constructor, I give a value to that property. The selector up here, so this decorator is adding some extra behavior to my component. It's doing two things. Giving a name to the HTML tag, so that's app hello in that case. So if I want to have this component show up on the screen, all I need to do is add this app hello tag in my HTML, and then this is going to show up. And then it has an HTML template. So that's what we're going to render when this component shows up on the screen. So we have to build that upon existing tags, of course. So here just a div and a title that says hello and the name that comes from down here. So if I go to my application instance, that's the main for my main application component. So you see that we have a navigation bar here. That's the Jumbotron with a custom title and a custom description. And that's my license plates down here. So you can see that structure clearly. And if I wanted to add my hello component to the mix, I could do app hello in the middle of here, for instance. And that would end up loading the following components. That's going to say hello name. Let's have a default value of Angular for this. And now when I go back to here, it actually shows up behind the, so that's because of CSS. I'm going to put it after the Jumbotron. Down here. And yeah, there it is. So that's my component that says hello Angular. If I select it from here, yeah, that's my app hello, and you can see the template that shows up inside of it. So that's a template that comes from the following code right here. So in the end, Angular is very basic. When you create a component, you give it a name, you give it a template, and then you have some data that's going to be used in that template to be rendered. Easy enough, right? And you don't have to register any event listener or anything. If the value of name here changes later on, then Angular is going to take care of refreshing that component automatically, which I can show you right now. So let's add a constructor, for instance. And in that constructor, I'm going to use setTimeout. Does anyone know what setTimeout does in JavaScript? Yep. Yeah, it's like a timer, so it's a way to delay some code and make it run in the future. So what I'm going to do here is assign a new value. And that value is going to be something else. And this is going to happen after 5,000 milliseconds. So that's 5 seconds. So all I do is change the data. Just assign a new value to that variable. And I go back to my browser, it gets refreshed. So right now it says hello Angular. The timer is running. And then it says hello something else. So if the data changes, the component re-renders. And you don't have to do anything, really. Just change the data, and the component is going to see that change and automatically re-render its templates. So that's the main important thing to know about Angular. That's the main feature, really. It does all of the hard work of getting the data and displaying it just because it's going to watch for that and see changes and just generate the HTML out of it. Questions? So far, so good. Seems easy. So the best thing about this is that if I want to create a new component, let's say right now I decide that I want to display a dashboard somewhere on my app, I can just ask Angular CLI to generate a new component for me. So ng generate component, I would call this dashboard, I run that command, and it's going to create it, to create all of the files needed for my component. Oh, I already did that. And that's because, yeah, I did a demo this morning. So let's create dashboard v2. So that's dashboard v2. It created a new component. If I go to my browser, we see dashboard v2 just showed up in my IDE, And that's all of the code, really all of the default structure of that component was automatically generated for me. So now all I have to do really is change the HTML. I just add something custom in here, and that's my component. And now if I want to use it, I put it over here instead of my hello component. You replace this with dashboard v2, and done. I have a new component that's going to render on my screen right there. Yep, dashboard v2 works, I did it. So creating a new component was just a matter of seconds. You run that command, you have everything needed. Just add your HTML, your data, and you can use it right away. So that's something the Angular team has been working very well a lot on it to make things as easy as possible so you can get productive and get your code to production very quickly. I guess that's why they push stuff once a week, because they have all of these tools that make things faster. So that was an Angular component. So my component, when I generate it, you see that the template for that one, for the dashboard, was not in TypeScript. It was referring to an external URL instead, and that's the best practice, so that you have one file for your TypeScript code, one file for your HTML template, and one file for your CSS for that component. And every component is going to have these three different things: TypeScript, HTML, CSS. Which means that dashboard could have its own custom CSS through some styling, of course its own template, and then its own business logic in here to get some data to render. So the good news is that we saw that we can create components easily, but we don't even have to do that most of the time, because Angular is popular, and because it's popular, other companies have already created open source component libraries for us. So, for instance, one of them is Angular Material. So this one comes from Google as well. It is using the material design specification from Google. It's what they use for Android. So if you have an Android phone, that's the look and feel for Android, basically, translated into web components. So all of these cards, all of these text inputs, that's the Android look and feel that you have when you use them on the web. The good thing is, as you can see, they're very involved. So when I click on that input, you see all of the CSS transitions, the font, the text that goes up here, the size changes, the colors, all of that comes with that library. And if I want to use it, what do I need? Well, it's just one component. It's a material form field. So I just copy-paste that code, and I get the following as a result. So I don't have to worry about styling, about sizing, about animations or anything. It's all shipped with that component. And then I can build my app using these components that were pre-made for me. So text input, probably not a big deal, but a date picker, for instance, that's a tough one. You don't want to write your own date picker. So you can use the one from Angular Material, and it does the job very nicely. So move to different months, select the date, and all of that. So there's many different ones. They have a slider as well, which looks pretty good. They have side navs, toolbars, grid list, tabs. Yeah, tabs would be tough to write. So these tabs here, that's Angular Material. The same thing when I click, there's animations, transitions, all of that CSS code that would be very painful to write, to get it for free. If you don't like the colors, they have default themes. Some of them are a little bit more flashy, right? But it's the same library. They just change the CSS behind it. So just with one click here, everything changes to a different style entirely. And different colors and everything. And you can create your own. So you can just use that library and then override CSS to just make it fit your brand. And a few months ago, my own bank decided to do that. So when I go to the website of my bank, I can recognize the Angular Material buttons here. but they use their own color, so it's green and black and white and all that. And that's the input. See the transition and all of that? This is material design. But customized so that it fits a corporate brand, and it's not just pink and purple and black, which is what they do by default here. Maybe not the best way to sell it, but yeah. So that's one example, Angular material. You can access all of these components for free. It's open source. You can use them out of the box, and that's all good. Another example of such component library is VMware Clarity. So this one doesn't come from Google. It comes from VMware. And so that's what it looks like. Just different CSS, but they have very similar components. So they have their own date picker. That's what it looks like. You can also customize it. They have a data grid to display some info in a table where you can select some rows and all of that. Labels, lists, progress bars, all of that, you name it, it's just components. So the code behind it is super easy. It actually has a few examples here. Code and examples. It doesn't want to go there. But yeah, they're components. So it's as easy as using the name of the tag. Yeah, there we go, that's one here. Progress. That's a progress bar component. So you just use that, pass the value you want to display 65%, and it's going to show your progress bar at 65%. So we don't have to write all of the components. We can reuse many of them written by somebody else, which is really nice. So now you know everything about components, almost. There are custom HTML elements we can use, some of them written by other people. And now data binding. So that's another very important feature of Angular. Data binding, that's what makes everything dynamic. That's what makes, when I change the data, the HTML reacts to that and renders those changes. So data bindings, you can apply them anywhere in your code through a syntax trick, which is these square brackets here. So if I put these square brackets on any HTML attribute, that creates a data binding. And then the right-hand side of that assignment is now an Angular expression. So name here would refer to a property in my component class. And that property is now bound to the value of that text input. So if the name changes, then the input is going to reflect that change right away. I can show that to you quickly. Let's start my quick demo on this. So that's the text input. I added these square brackets to get the Angular magic in here. This is bound to the name property that has this value, a test. And then there's a set timeout. So after 5 seconds, it's going to change to another value. So if I go and display that demo, localhost 4201 is where it's happening. I go to my binding example. So that's my text input. It says a test. After 5 seconds, it changes to another value, thanks to my data binding. And you probably saw that in here, there is a button. And that button has a click event listener. So we're using parentheses here. And parentheses are what you use in Angular to create an event listener. So here I'm binding another Angular feature on the click on that button. And it's going to call the alert name method in that component. What does alert name do? Well, it's just a JavaScript alert to display this.name was clicked. So when I go back here, click the button, another value was clicked. So these are one-way bindings. And it's just one way, meaning that if I change the value in here, So the value is now changed, but it's not going to be changed in my TypeScript code. So when I click the click me button, it still says another value was clicked here. If I want to have a two-way binding that works in both directions, so from TypeScript to HTML and from HTML to TypeScript, then I would have to use something slightly different here. And that is called ng model. Because it works both ways, we need both the square brackets and the parentheses, which is a little bit surprising in terms of syntax, but we get used to it. And now we have a two-way binding, which means when I go back here, it's going to refresh. Now it says a test. I'm going to wait for 5 seconds. Another value. Now if I change that to something completely different and click me, the value I entered was reflected in my TypeScript code. So it's now being displayed when I click here. And these bindings, well, they're super powerful. I can decide to have another expression down here to render that binding, for instance. And just by doing this, now when I get back to my demo, you see that the text down here comes from that binding. And if I edit it, it just gets updated in real time. So bindings, you can get very creative with that and make your code very, very dynamic without writing any code, really. That's what I did. Just I did one binding here and one here. And this is how these two things get updated as one or the other changes. So very, very powerful. And we can go one step further. You'll see that here I added another binding. And this one is on the button. And what it does is that it's binding the background color of the button to that same value, name. So why would you do that? Why would the name be bound to a background color? Well, that's just so I can do this and have fun. If I type red, then my button turns red. If I do pink, then it turns pink. So you can imagine many different use cases for that kind of thing. You can use bindings to display an error message, or hide it, or highlight something that has to be filled out by a user, for instance, in a web app. All of these things, you can easily translate that in simple bindings, just like this one. So you don't even end up writing any JavaScript or TypeScript code. Because for this component here, so yeah, but
it's haunted.
yeah, that works. So that's really the only line of active code in here. This was just to illustrate that if I change the binding, things will work, and that's my alert. But yeah, I've wrote literally no JavaScript or very little of it, and I get all of this for free. Yeah, still working. So that's bindings and what we can do with those. So I've talked about all of these things. You can also do some things that are a little bit more complex with bindings. So you can use something like this, like express conditions in your bindings. In that example, if we have any error, the message would show up in red. If no error, then it shows up in blue. So it's an if and else statement inline in your template to customize the styling. And this one down here would just hide the error message if we don't have any error. So very, very common use cases for Angular apps to do that kind of thing. Any questions? All good? So we talked about components. We saw that components make what we display on the screen. The next big thing that Angular has is this notion of directives. And a directive, what it is just a way to make the DOM, to make the HTML even more dynamic. So in our example, in our store, we have many different license plates that we want to render. And in order to do this, we use a directive called ng_for. So ng_for is just a way to loop through an array of data and display as many elements in the DOM as we need for that array. So this example here would take a list of persons and generate many different list items for every person in that list. In our example, in our license plate store, we have many different license plates. And the way this works is that I have a directive that's just going to repeat this license plate component as many times as I have data to render. So if I go to my app component HTML, that's my app license plate component. And you can see that I'm going to remove this so it's not confusing. That's my ng_for. So this is repeating that element as many times as we have license plates in that array here. So that's an array of license plates with data that comes from here, and that's the array with all of my plates in it. So it's just JSON data that will come from a backend, and that has all of the info we want to render. So we pass that to ng_for. ng_for generates all of these components, and then that's what we get on the screen. Many different license plate components. So there's 8 of them in that list. So that's an example of directive. There's many more. I can showcase one more example, ng_if, which is just going to show an element or hide it based on a condition. Let's go to my license plate component here. And what I want to do for these license plates is that when a license plate is on sale, I want to have a sale tag that shows up next to the title. So if it's on sale, I'm going to put a sale tag. If it's not on sale, I just don't display anything. So these license plate objects, they do have a on sale property. So that's the other nice thing about TypeScript. Because it is tagged, I can create my own types. So here I created my own license plate interface that has all of the properties of the license plate. So on sale is a Boolean, true or false. The picture, title, price here, all of this is data defined in that interface. And because I told to my component that the data it would get is a license plate, when I go to my template here, you'll see that I get assistance from my IDE. So it knows all of the different properties I can access from a plate because of the type info that we gave earlier. So that's another big benefit that we get from TypeScript. So in my case, I just want to add an image here. As I mentioned earlier, I'm going to add that image. So img src, it's in asset/sale.png. And this is going to show up only when the plate is on sale. So ng_if plate on sale. And that's it. Just added that image tag, and it's going to show up for all license plates that have on sale equal to true. So when I go back here, you can see that New Jersey is on sale, Colorado is on sale, and New York is on sale. So that's what directives do. They allow us to repeat an element or show or hide an element based on some condition and make all of that even more dynamic. So everything you see on the screen here is just Angular based. So we have 1, 2, 3 different kinds of components. We have 2 different directives that make these things, that repeat these things, make them dynamic and all that. Any questions? Or anything you'd like me to showcase that I didn't talk about? Or any feature that you don't see how we would do this with what I just mentioned?
Do you think DOM, CSS, and JavaScript is good enough that it'll be around in 20 years, or is there something else that will come along as a plan?
You mean to render things on the screen? Something better than JavaScript and CSS?
Yes. Is this going to be here in 20 years? Well, I've been in the industry a long time, and things keep change is eternal and constant.
Yeah.
So what's next, or is this?
That's a good question. So there's something that's growing pretty quickly, and that's called WebAssembly. WebAssembly, I don't know if it's going to replace HTML, JavaScript, and CSS, but what WebAssembly allows you to do is run basically C or C++ inside a browser. So you can replace this entire browser window with any code you want. You can do your own thing. You have full control over everything. And that's what WebAssembly does, basically. So that just opens the door to anything, right? And the ability to do video games in the browser, even more than what's been there in the past. And there's a bunch of video games that are already based on WebAssembly. They use 3D engine that they just put in there in C, C++, and use the native resource of the machine to make things happen. So with that, of course, no limits. Well, limits are what your machine allows you to do, but in terms of graphics and the way things look like, there's pretty much, it's like a native platform. The downside of it is that that content cannot be indexed by search engines. And for the web, that's kind of an issue, because Google doesn't know what to do with a WebAssembly app or website. It doesn't see what text is in here and how to index that. So that would be the only thing that makes this maybe not fully the future, but there's potential, and it's being used more and more. But is it going to replace everything? I don't know.
So you would need a different executable for each platform, like Java. I mean, for Mac versus PC versus Linux. I'm not sure. I think when you use WebAssembly, the browser kind of acts as a virtual machine, which makes it independent from the operating system. Not sure. To be checked. Never used it, but.
Microsoft has one that they're pushing right now called Blazor. You write C#, and it I don't know if it's transpiled or compiled into.
Well, yeah, the output is some WebAssembly stuff. Yeah.
You run WebAssembly, and then it's just the browser interprets the WebAssembly. It has nothing to do with the operating system. Yeah. So it's basically, from my understanding, it's like Angular, but in Microsoft. You said C#? It's called Blazor. Yeah, you do C#, whatever definite.
Yeah.
So you can use. I think you should have Sharp or C#.
Yep. And the output is this.
But I think there's a Python one out there. I think there's a Go one. There's a couple projects out there.
Yeah. But yeah, I guess the biggest thing about it is it cannot be indexed. That's what kills Flash. So this is just another kind of Flash, if you think about it, right? So
I mean, it's kind of similar to like the way that JavaScript went, where people were on the front end running JavaScript and they wanted to be able to write backend code, so Node.js came out. It's kind of the same way where people write backend code in Python or JavaScript or C# or Java, and they want to be able to do front end. So you can.
Yeah. So yeah, we'll see. That's the only thing I can think of that's really different, and that's up and coming.
Well, I thought WebAssembly still used HTML and the DOM for rendering, but
No. There's no DOM with WebAssembly. Probably that you can use some if you want to from WebAssembly, but yeah, you can port any existing video game using the Unity engine, for instance. They ported that to WebAssembly. So any video game based on Unity, you can just run it here, and that's all good to go. But most of the demos that run now, impressive video games with thousands of things going on the screen. and it just runs natively, kind of. But HTML, CSS, JavaScript, they're all evolving very, very quickly. JavaScript especially is moving very, very fast these days. For instance, they are adding Bluetooth support directly in JavaScript. So a browser just with JavaScript could access some of your devices around here through Bluetooth in JavaScript. So it's not going to die anytime soon. They're doing more and more in JavaScript. And that's Google's philosophy anyway, just to push everything as far as they can and see which one wins in the end. So they're going to be pushing Angular and JavaScript and WebAssembly and all of that, and Android, even if it seems to be completely in contradiction, like Android versus Angular, or even versus WebAssembly. They're kind of competing to do the same thing, but it doesn't matter. They just push all of these things and see which one's going to win in the end.
You mentioned 1,500 projects at Google.
Yep.
Are a lot of those accessible to the public, or are they internal projects for internal use?
I don't know the exact proportion of which ones are public, which ones are not. I just know for sure that some of YouTube is with Angular, some of Google Analytics, and Google Analytics is crazily complex. It's a user interface with a chart, and everything is dynamic and maps and stuff, and just moving around. So they use a lot of Angular for that. Internally, another one that I know is using it. I think is the Google. Is it Google Checkout? Yeah, I think it's Google Checkout. This one is fully made with Angular for sure. No, that doesn't look like it. The other thing with Google is that they rename all of their projects all the time. So
Never know what it's called this week.
yeah, Google Pay. I don't know. The other one I had in mind was Google Merchandise Store. Yeah, that could be the one. Oh, it's actually loading on my screen. There we go. But just a store to buy Google stuff. Oh, there's too much loading. It cannot be Angular. It would be a little bit faster than that. It's using material for the CSS for sure. But yeah, that's a good question. I should try to find which ones are fully public.
But 1,500, I can't think of 30 or more than 30 or 40
Yeah.
things. I'm going 1,500. What the heck is that?
Yeah, that's a lot. Now, some of these things are probably very tiny. Like, a dev team, they have their own kind of app to manage something internally, and that's one project. But they count in the 1,500. So not everything is huge like YouTube or Google Analytics.
Is the generated code small, or does it include a lot of libraries to load it up to something large?
Oh, that's another very good one. So for this, I'm going to show you, well, the real thing, meaning my project here. So this is a store that was built. Let's go to my file system. So I go to NG2 training, that's the one where everything is. And if I take a look at this, you'll see that this is massive. That's 549 megabytes of code. This project, all of the code, all of the dependencies, the Angular CLI, all of that, 549 megabytes. That's way too big, right? Now, if I ask Angular to create the production version for it, I would do ng-build /prod, and that single command is going to go through all of that code, and it's going to compile it. It's going to minify it, obfuscate it, so rename all of the variables like A, B, C, D, E, so the names don't mean anything, so it's difficult for a hacker to understand what the app is doing. And it's also going to do something that's very specific to Angular called tree shaking. And that tree shaking is just going to see what we are actually using in the app and keep that code and remove everything else.
So it tracks it.
Yeah.
Turns off the stuff you don't
Exactly. Everything you don't use just falls down. So they fix a tree of all of the dependencies and everything falls down and you just keep what you actually need. So if I use, let's say, Angular material and it has 100 components and all I use from it is a date picker and inputs, I would only keep that code for my production app and everything else gets removed. So ng build completed. You saw that it took some time, 36 seconds almost, to do that build. And the reason why it took so much time is because it had to go through these 500 megabytes and figure out what do we actually need, what we don't need. And that's the output size.
Wow.
So from 545 megabytes, now we have 0.8. And all of this is optimized for prod. Meaning that if I show you that JavaScript, so let's open it in WebStorm here. I go to my dist folder, so that's the output of my build. And that's what the code looks like. So all of the extra spaces, new line characters, everything is gone. And all of the variables have name like T, E, N, R, O.
So how do you debug runtime errors? Do you keep a variable map of whatever you need?
So this is production code,
Yeah.
and you're not supposed to debug in production. You can see that kind of as the bytecode, like it's binary almost. It's not really, but that's the way you would think about it. That said, when I'm doing my dev here, if I want to debug, I can actually debug in the browser, right here.
Production code in the field
Yep.
sometimes has errors, so
Yeah, and the best way to debug it. So I'm going to show you how you would do it in dev, and then I can explain how this would work in production if you do want to debug in production. So I'm going to add a breakpoint somewhere in here. So we have a license plate component. Where can I put it? Maybe here. So I'm adding a debugger statement in my TypeScript or JavaScript for that matter. This is a breakpoint. So when I go back to my app, now it stops on that breakpoint when it's. And as you can see, what I'm debugging here is my TypeScript code. This is my TypeScript stuff. It's not JavaScript. So even if my browser is running JavaScript, that was compiled and is very different from that code, the way it's done is I can still debug step by step using TypeScript inside the browser, which is very, very powerful because I never have to worry about the output of my build or what the actual code looks like in the end. I can still debug from what I'm working with, which is TypeScript.
Using the source map to
Yeah, exactly. So what's happening is that the compiler is generating source maps. So that's files that do the mapping between my TypeScript code and where it actually ends up running in JavaScript. So that the debugger ends up stopping in the right place in JavaScript and has all of the mapping between the variables and everything. So if you want to debug in production, you could run your production build and add the option to generate the source maps. And that way, if you have the source maps, you can do exactly that and see the TypeScript code and do breakpoints and all of it. It makes the build bigger, of course, because the source maps, well, they're pretty big. They have to do all of this mapping between JavaScript and TypeScript. But if it's temporary debugging, then why not? So it does require a little bit of effort to debug production, but at dev time, super easy. So how are we doing in terms of time? 1 hour-ish? Yeah.
On the CLI there, where it generated those component files, what's the spec file?
So that's a sample unit test. Every time we create a new component or anything with Angular CLI, it gives us a sample unit test. to test that component. So just to help us write more tests, they generate the default structure for it. Even if this one doesn't really do anything, it just makes sure that the component exists, basically. Expect component to be truthy, which doesn't really do much. But you have the structure, so now you could start checking that the component displays the right information and that kind of thing. So all of that is also included with CLI, and that's why I have 545 megabytes of code, because all of the testing framework, testing reporting, test runner, it's really one big box with everything in it. So you never have to bring any extra dependency with Angular and Angular CLI. You can run all of it from one place.
Does Angular have a test runner then? Or do you run
Yeah. Mm-hmm. Oh yes. Yeah, if I want to run my tests, I just go here and I run ng-tests. And just like ng-serve, this is going to find all of my unit tests, compile them, open the test reports live, and show what's going on. So yeah. And you get that just with the basic install of the framework. No need to set up anything else. So and give it its result. So Chrome is showing up now. Run the test in it, and then complete or fail. Probably fail. So I messed with the code quite a bit here. Oh, actually everything passes. Wow. That's good. I should take a picture of that. This never happens. So I have 12 unit tests. All of them are passing. That's great. And this works just like ng-serve. So if I change my code or add a new test, it will see the change, recompile, rerun in the background, and update that report live. So yeah, that's pretty good. Let's see. Maybe I can showcase one last thing on Angular before moving on to Cypress. Because everything I've showed you so far was client-side. So we have this store now that's running, but it's not getting data from a server. It's all running in the browser right now, and the data is hard-coded, which of course is not very realistic. So in real life, we would take that, we would make a request to a server and get the license plate displayed here. So let's do that very quickly. So the way to do it is to use an Angular feature called the HTTP client. And this HTTP client, you can use it to make any kind of HTTP request. So here I'm making an HTTP GET to localhost 8080/%.json. This is going to return some data, but it's all asynchronous, right? We make a request, we wait for a few seconds to get the result, or milliseconds, and then we get the data. So when we make an HTTP GET, we get an object as a result that we subscribe to. We pass a callback function to it, and that's how we receive our data. So let's see if I can apply that to my store very quickly. I'm going to go to that service. So right now it's returning that hard-coded list. I'm going to comment this out. I'll just remove it. And instead, I'm going to tell Angular, hey, give me the HTTP client here. So Angular is going to inject that HTTP client in my constructor. And now that I have that HTTP client, I can make an HTTP request to http://localhost 8000/data. And then I would subscribe to that. This is going to give me some data. And this license plates equals data. And then I would use those license plates to display them on the screen. So just assigning that data to that property is going to make my component show those license plates that came from the server. So let's declare it up here. Yeah, I'm going to do the very quick version here. Actually, I'm going to change that a little bit. do it that way. That should do. Oh, it's complaining about the type here. So I can provide the type information to TypeScript. And what I'm doing now is I'm telling TypeScript that the data I'm going to get from HTTP GET is an array of license plates. So I'm giving the type of the response that I'm going to get from the backend. And then my component is already ready for that. So if I go back to my main component here, it's calling that method, subscribing to the result, and assigning the data to license plates. So with that in mind, if I have a server, which I'm going to start quickly, so my server is running, that's my license plate server. If I go to localhost 8000/data, it's returning my array of license plates. So it is there, it is my backend. And now I go back to my store, and we don't see anything yet. Looks like I got an error, but I think it's just a refresh issue. Yeah, it's run before my server was started. And now that's my data. But this data here looks the same as before. Only difference is it now comes from the server, which we can see from the network tab in here. Yeah, that was my request to localhost/data. And it was a GET request, the status was 200 OK, and that's the response that we got, an array of 8 different license plates. So if you use JSON data on your backend, then it's all integrated with Angular already. And it's really just one line of code to just make the request, get the response, and then parsing that response, getting the data, displaying it is all automatic. So just make that request, get the data, assign it, done. So that's Angular. And that's how we can make, well, I made a store here with a few things on it with very little code. And if I deploy it to production, it's less than 1 megabyte. So that's pretty good. And with the next version of Angular, Angular 9, they already announced that all of the JavaScript is going to be 30 to 40% smaller for most projects, just because they were able to be even better at tree shaking. So they take a look at the code even more in depth and see, oh, this thing, you're not using it, let's remove it. This, oh, you're using, we keep it. And everything is going to be even smaller within a few weeks, just because of the framework itself. So that's really nice.
Is that for the Ivy, or is that all?
Yeah, so that's what's going to come out with Ivy. So the Ivy renderer is going to be able to give more insights into what we end up using and not using. Any final questions on Angular? Or do we switch to TypeScript? So if you want the link to these slides, it's right here. So there's a few more things that I didn't go through, because I could do that all day. That's what I did today. I would never stop. So now Cypress, topic number 2. Oh, actually, my battery's going to die. Oh, yeah, looks like maybe we can take a quick break if people want pizza or drinks, like 2 minutes, and then switch to Cypress. Oh yeah, there's in your yeah, just touching this would disturb it.
email address to so like part of the right? Yeah.
Thank you very much for food. Absolutely. All I have to do is go through the order sign.
One number to that. You guys have an elevator?
It depends. So this past few months have been crazy. I've been all over the place. September, I've been to UK, I've been to Australia, I've been to Bolivia. So yeah. Which was fun. Got to visit early places, but yeah, it was too much of I do better next year explaining it out. For training and travel, usually 1 to 2 times a month. That's my average. I try to be home most of the time and teach 1 week per month. This is the average pretty much. And this could be anywhere. So far it's actually pretty close from home. Yeah, good.
Not too bad.
Yeah, I like that. A 1 2 hour flight, but that's like nothing. It's a short commute.
Oh, right.
Yeah, it was intense.
So there's a lot of hours.
And the time is like finishing 18, so it's like, yeah, actually, I just did pretty good on the way back because I landed in San Francisco on Sunday. So that was just pretty good.
You have to do some laundry, minimal grocery shopping. Let your bed know you didn't forget about it.
So yeah, all of the things you see here are some of my training. So all of these cool examples, slide and things that I did all of it. Which is good because usually when I teach it's my material, so I know all about it. I know where to add some kind of tweaks or bits and maybe ideas around the thing, that kind of stuff. It's also a lot of fun, I think. Small interface I can maintain on the side, but not really on the side. Sometimes I know I need to create my That's why I did a store license space, because no one else did do it. Everybody has to do this. That's all right. I want to do something different. You know how to do this. So I'm going to get started with Cypress. Just want to make sure that my repo is clean and that things are going to work. So that I keep, that I don't.
We don't have any over.
Okay, it's working. So now end-to-end testing, completely different topic. So I'm going to talk about Cypress. I can skip the intro because I've already done that. We don't have to do the setup. So what is Cypress? So Cypress is a way to do end-to-end testing from A to Z. It's a complete testing experience. Everything comes with Cypress. So you write the test with Cypress, you run the test with Cypress, you get the reports with Cypress, you debug with Cypress. All of that is all in one thing. The way it works, so we're going to test our license plate store. The way it works is that you would write tests in JavaScript. The tests are going to look like this for the most part. So you have a describe function. That describe function is a bunch of unit tests. Well, not unit tests, a bunch of tests. So it's going to group a number of tests together. And then you have a bunch of it functions. These are the individual tests that you're going to run. So for both describe and it, the first parameter is just a string that describes what we're doing in here. So here, this is the test of my home page, and my first test is checking that we display the right main title. So that's a string that you provide just to describe what you're doing here. And then the actual test here is using Cypress, so that's a CY object to visit my license plate store. So if I want to run that test, so that's the code, that's what it looks like. I just change the URL to run locally on my machine. If I run this thing, I would go to a terminal and run npx cypress open, and this is going to open the following window, and from there I click on my test file, my test spec, and I just did it a few seconds ago. I have to stop first. It's going to run those tests in here. So you can see that Cypress took over Google Chrome. So we see Chrome is being controlled by automated test software. We have this left toolbar. So that's a description of my describe function. That's a description of my individual test. We see that it passes because it was successful. And that's the user interface that was loaded. So that was one very basic test. I actually didn't test anything in here. I was just displaying the page. But Cypress does all of that. So all of the integration is there. And just like earlier with Angular and ngserve, if I go change my test, it's going to see it and rerun that right away. So it's all automated. So let's say I want to change that one. And what I'm going to do now is check the title here. So I want to select that title. So what I can do is use this selector playground that Cypress gives me. So I click here, and then I go select an element on my page. So I click on the playground, I click on the text, and it gives me a selector to select that HTML element on the page. And once the element is selected, well, I can check that it's displaying the right thing. So Cypress gave me a selector. So let's copy that selector and use it, paste. So this is going to select the title element, and from there I can check, so I can run some assertions. So this is the text. I want to, well, I'm actually going to do it even better, as a better example to get started. So that I did. I'm going to start with content because that's even easier. So content is going to look for some text. on the web page and select the HTML element that contains that text. So that's even easier than a CSS, than any kind of selector. Just, hey, by the way, Cypress, check if we have welcome to our store on that web page. If it is there, test passes. If it's not, test fails. So I change this. It's running again. And you see that contains worked. It did find the title of my web page, so all is good. If I made a typo in my test, for instance, then the test is going to fail. So it's going to rerun, and now you see that content is running. So what's happening with these selectors, and that's one of the things that makes Cypress great, is that a selector is not going to fail right away. If an element is not present, it's going to retry for 4 seconds. Because it knows that modern websites, all of the stuff is loading, asynchronously. So it could happen a few seconds later. So it's going to wait and retry and retry and retry. And then after a timeout, it's going to say, oh, I didn't find that text. Welcome to blah, blah, blah. So it's just not there, and then the test fails. So there's a 4-second timeout by default that you can change. You can make it longer if you want to. And that's what happened here. So the text doesn't exist, the test fails, and I know that I have to change something, which I'm going to do right now to fix it. So that's contains, and that's really the easiest way to check that anything is present on my web page. So that's a way to select an element and make sure that it is right there. Then once I have selected an element, I can run a bunch of assertions on that element. So here I'm going to check that this welcome to our store is visible, for instance, and that it has a font weight of 300. So I can check the CSS, I can check the size, well, anything really related to whatever you want to test. You can go as deep as you want. Check the font, check if it's bold or not, all of these different things. So in my example here, I'm just going to add a should be visible. So all of these different assertions come with Cypress as well. So it's going to rerun my tests, and everything happened, and the assertion here is green because it passed, so that the element was indeed visible on my screen. So get is the other selector. So we have content that's going to check for text, and get is a CSS selector. So it's going to select an element as you would select it with CSS. So here, if I do cy.get h1, it's going to select all of the h1 HTML elements on my page. And that's where you can use what we saw earlier, the selector playground, to get a selection that's unique. So this one would select the same element. It just matches 1 on this entire page, and I could use that for my test. It's just a little bit more complex to read when you use those, because while most of the time they're not as explicit as using the actual text that's used on the screen. But that's another option, and that works pretty well too. So I could check that, let's say I want to check that we have this search button. So I'm going to get this one, so that's a selector for it. I'm going to copy it to the clipboard, paste here, so that search button, it should be visible as well. So that's the second thing that we're checking here, and that should pass too. So now we have 2 different assertions, and all is fine. And of course, when you test your entire application, you would write more things. So you would check that all of the license plates show up. You would check all of these different things, which would look like this, for instance. So here, I create the first test where we go to the store. We check that the title is all good. So checking the CSS, the font family, all of these things. And then I want to make sure that we have 8 license plates displayed in that store. So I go to that page. I select all of my license plate components. And that's where it kind of helps to have Angular, because with Angular we have components And because these components are our own HTML tags, I can say, hey, select all of the app license plate components. And we should have 8 of them. So with one single line of code, I'm checking that 8 different license plates show up. So let's run that one. That's demo number 2. Now we run a test. The first one passed. And the second one, see, it's waiting. And oh, we're getting nothing. Oh yeah, I went to the wrong location, that's why. I have to change those to localhost. Well, actually, I can even cheat a little bit. And refactor this. I'm going to change these two. And just change the base URL in Cypress. So Cypress has this config file where you can define the base URL for your project. And that's what I'm doing right now. I'm saying that you'll find the base URL for what we're testing is localhost 4200. And now in all of my tests, I can just say visit / and it's going to go to that URL. So / is relative to the base that we defined here. So that should fix it. Let's run that test again. Yeah, the license plates are here. And my 2 tests pass. So we see that, so that's the 8 different license plate components that were selected. It gets highlighted when you go over the selector, so you can see exactly how the tests work and all of that. So these options that I just showed you, you can define the default timeout as well. So here that would set it to 10 seconds instead of 4. There's many more options in Cypress. We can see them from that window here. Let's say if I go to settings, configuration. So this shows all of the different values from Cypress, and it highlights in blue the ones that I changed. So I updated the base URL. So that's my own config. Everything else is a default. So that's where we see that the default command timeout is 4000. And you can override all of that, provide your own values if need be. Because sometimes 4 seconds is ambitious. So you can interact with things on the screen. So for instance, this would be a simple set of commands to log in an application. So I would select the HTML element that has the login class and type an email in it, select a password and type the password, and then select the submit button and click on it. So that would simulate someone entering username, password, click on the button. And you can also simulate keys being pressed. So if you do that kind of thing, get the form and type enter. There's actually a typo here. That should be dot type enter. Yeah, like this. So this would type enter on the form and make sure that it gets submitted, for instance. So you can simulate all kinds of user interactions with your application. In my case, I do have a few tests for that, because this license plate store, it has multiple pages. So one is a cart page that we want to be able to navigate to. So see, that's how I would translate all of the different actions, find the link to my cart and click on it, and then make sure that we see the following text on that page. Make sure that you can go to the checkout page, and that the text shows up in here. So all of these tests, you can express a lot of things with just 2 or 3 lines of code. That would test the entire navigation in my app, make sure that the products show up, and yeah, it's testing quite a few things.
noticed your tests have the same .spec.js extension. Is that the same with the Angular test, or is that just a conventional?
That's just the convention that they were using a lot in JavaScript for tests, yeah. So, yeah. So Angular was TS for TypeScript, and this is JS for JavaScript. You could also use TypeScript with this, by the way, if you wanted to.
The spec part.
Yeah, the spec part is the same, even though the tests are quite different, yeah.
The spec whatever is usually.
Exactly, yeah. That would be the convention. So one thing I want to illustrate with this one, navigation. Yep, this one. The navigation to different places. And in that example, I think it's going to fail because it's not implemented yet. So yeah, we hit the 4 seconds timeout, the test fails. And then we're going to hit another 4 seconds timeout, the test fails. And this is good because I can show you that Cypress allows us to time travel. What do I mean by that? I mean that I can go back in my test here and click on any of these steps, and it would show me the state of the DOM of the web page back then on that instruction. So when something fails, you can go back. You don't have to rerun the test and watch what's going on. You can just click on any of these steps, and it's going to show you the state of the screen back then. So if I go to the very, very beginning, I can probably get to a point where, I got the plates loaded directly here, so they show up right from the start. But if I was testing something different, where the data takes some time to load, the initial steps, the screen would be empty, or we would have a loader, a spinner, that kind of thing, before we see the data. So you can time travel, which is really nice. Yeah, another thing that it does when you have some instructions is it can show you before, after. So before you clicked and after you clicked on something, so you can see the transition and what happened as a result of the click. Yeah, that's an example here. So that's the click instruction that was supposed to click on the My Cart link. So before, that's what it looked like. After, that's what it looked like. So there was no transition because, well, I don't have implemented the cart page yet. But if there was something different, we would see it here. And I guess for this one, I could use my other. Yeah, I'll do the other store, because this one is going to have the cart page, just so we can time travel a little bit. So angulartraining.com, I'm going to remove this test here and rerun. So now everything should pass. There we go. So that's the before state. That's the click, before the click, after the click. So I can see exactly what my click did on the screen and what was the transition to get there, which is really, really nice.
Are those screenshots that are saved, or is that actual DOM state?
That's the DOM. So you see, if I go over things, it still highlights and everything. So it's really restored the way the HTML was back then. So I can explore it. So I can open the DevTools in the browser, watch what's going on, explore the DOM, debug, basically that. And another nice thing that this allows, so this is good when you're working on your tests on your machine and running them, but most of the time what we're going to do is do that with continuous integration, right? So you're going to have a tester that's going to run these tests on its own. Cypress also gives support for that out of the box with npx Cypress run. So npx Cypress open and have this kind of interactive mode. Cypress run is just going to go through all of the tests in my project and run everything in command line. So we don't see the browser in that mode. It's just going to run everything in the background using Electron headless as a browser. So it's running the same test, and when it's done, it creates a video recording of it. So that if something fails, after the fact, I can go back and watch the video and see what was wrong. So that's pretty good. Because now you can have this running in the background or on a continuous integration server. Oh, it fails. Let's go watch the video. Oh, yeah, I forgot to do this or that, and you can fix it. So now it's running as a command line tool. And in my project, you'll see that there are two different things. So one is screenshots, where it would take and put screenshots of success, failure, both. It depends. You can configure that. And same with videos. So I get videos of all of my tests that run with that command. And when you watch the video, it's basically the browser window with the Cypress toolbar and everything. So you have the full picture of what's going on. So I'm going to stop it because this one can take some time, a few minutes, to run everything. So let's you have support for continuous integration out of the box. Doesn't require any extra setup, which is perfect. Any questions?
Have you done much, speaking of continuous integration, have you done much with it? I know that I've seen some more of that with running in containers, such as like a Docker Compose, or have you done anything with that?
Nope. I don't think it would be much different, though. So all you need for Cypress is Node.js. It's running on Node.js. So if you have NPM and Node, you can run Cypress, basically. So if your container does that, you're good to go. Plus, well, Chrome and Electron get installed with Cypress anyways. So yeah, that's really all you need. If you have a container that can run Node, you can run Cypress. Yeah, next thing I want to show you is that, so we saw all of the Cypress command, visit, get, contains, but you can create your own command if you want to. So very likely when you have a web app, you'll have some actions that are always the same, like login, logout, that kind of thing. And you can refactor that code and create a specific command for Cypress. So that's what I do here, cypress.command.add login. So login is the name of my command, and that's the code that I'm going to run behind that command. So it takes two parameters, an email and a password. And what happens when I want to log in, I go to the login page, I type the email, I type the password, I click the login button, and done. That would be my process to log in. And then when I want to do that in my code, well, I just do cypress.login, pass the email, pass the password. And that will run these 4 different instructions. So you can make things even more easy to read over time by just refactoring your instructions into meaningful commands. And in my example, for instance, to test the license plates, I could do that. So that's in support commands. And I created a command called check license plate at. And what it's going to do is select a specific license plate at a given index in my list of license plate components. And then I check that it contains a specific string and that it is visible. And I went one step further. So this takes an array of things to check. And I'm just looping through that array of things to check to make sure that they show up properly. So because of that trick, what I can do is the following. Oh, not that video. I want to get to the actual test. Integrations, Timeouts, custom command. And now my tests can go one step further and make sure that we have 8 different license plates. And then make sure that the first license plate displays the following text and has the following price. And I just repeat that 8 times to check everything. So it's super easy to read, kind of like an array of all of the expected values. And yeah, that's my custom command here that we find in the other file. So I cannot find any bad thing to say about Cypress. Yeah, it's just very easy to get started with. I mean, you get really productive using this. You can write tests that do a lot in very little time, and that's great. The only downside, if I have to find one, is that right now you can just do Chrome or Electron. So if you want to run these on Firefox or IE, you cannot do that. And that's the only bad thing I can say about Cypress. Everything else is just nice. But they're working on it. They're working on Firefox support and other browsers. So hopefully, in the near future, you'll be able to just run that on any of these browsers, which would be even better. Because now you can just write your test once and have them run on all browsers and give you a result. So that's even better.
Is there a way to share data between your app and your Cypress test, like run a JSON file with those 8 license plates and then hard coding it so you can reuse it in both places? Or is that not good practice?
So you mean instead of having all of these strings here, kind of define a file and put that in here? And,
Load them up from a file or
yeah.
database?
Yeah, you can do that. You could have that data in an external file, get it loaded in here, and then just read variables from that thing that you exported. Yeah, it's definitely doable. And the final thing I want to show you about Cypress is actually a way to mock the server. Meaning that right now I will be testing the actual app in its real-life context, which is good, but doesn't work all the time. For instance, my license plate store, in its final version, we're supposed to be able to change the currency. So you're supposed to be able to change from USD to euros or British pounds. And the exchange rate, well, it could be anything, right? Because this changes all the time, the exchange rate. So when I write my test, I want to be able to kind of set the response from the server so I know what I'm going to check my data against. And that's what this would be doing. So using Cypress as a server, we tell Cypress that we want to have our own fake backend, kind of, to replace some requests to the backend with our own responses. And here what I'm saying is that whenever we make a request to /demo/angular/rates.php, we return the following hard-coded response. So I just hard-coded 2 different exchange rates in here, so that's what I'm going to use as a response. And then Cypress is going to do that for me. So intercept the request, replace it with that fake response, and then I can run my assertions and make sure that the exchange rate was applied properly. So an example of this would be as follows. So before every single test, I'm going to start a server. I'm going to say, when you want to get the rates, return the following 2 things. And then in one of my tests, I would switch the currency to euros. So get to the currency switcher component, click on it. That's a drop-down that opens. Select the euro value in it, click on it, and then check that the prices are now all in euros, and that the exchange rate was applied from the USD value here. And that just works. So that's really neat. So this one, I could actually run it because all of the data is faked in here.
Can you explain what the as is on those 2?
Yeah. So what the as does is that it creates a variable that has the name rates in that case, and you can use that variable for, well, the main purpose of it is to do that kind of thing. So you can tell Cypress to wait for these 2 requests to complete before running the tests. So that would be the purpose of doing this here. A good example for that is you have a store, you have a checkout button. When you click checkout, it's going to do a transaction, take some time, and then get to the result. You could say, wait for the result to happen, don't time out, and then check things, for instance. So that would be one use case for it. Even if, again, in my case, I don't need that at all because it's within the 4-second timeout. So that was just to illustrate that we can do that if needed. try to run this one quickly. So Cypress is opening again. That's my last example. So now it's going to use, oh no, I'm missing one component. So it's not going to work unless I change one last thing. And revert back to this. Now that should be fine. So it's visiting that page. All of the tests are running pretty quickly now, and everything passes, including our multiple currency support. This one is actually pretty good for time traveling, because we can see everything. So at first, when we got started on that test, the currency was USD, so my prices were in US dollars. Then I clicked on the currency switcher. After I clicked on it, the drop-down opens. I checked that it contains euros. We selected euros. We clicked on it before the prices are in USD, after they're in euros. So that's perfect. Everything works. And then all of my assertions just passed because the prices are using the exchange rate that was hard-coded. So I know what to expect in terms of conversion. And that's what you can test for. So I don't even have to inject custom data to a database, to a backend to make these tests run. You can just do it nice and easy like this. Provide your own test data for some of the endpoints, or all of them, if you want to. But then it's kind of less end-to-end if you do it for everything. And yeah, these are very basic tests. But yeah, all of that. So what I just ran, that's 54 lines of code. So I can live with that.
Let's see, life without now. Is that just in this, I don't know what it's called, or described?
Sorry, can you say it again?
So you're intercepting these two specific routes?
Yeah, so the request I make to this endpoint and that one get intercepted. In that case, I just return this object. In the second example, I'm returning the contents of a file, place.json, that's located in the fixture folder. So that's kind of what you described earlier, where you can provide a file with the data in it. So here we're using the file as what we're going to return from the backend. I could also read that file to define my expectations down here, for instance.
And that's getting intercepted for the life of that one test, or for this whole, I guess it's before each, so I guess
So yeah, in that case it's within that describe, so all of the tests within that describe, because there's before each, all of them would have that applied. If I wanted to do it for just one test, instead of doing it in before each, I would do it just in the one that does the currency thing, for instance.
you have to have the server thing.
Oh, the server could be done here as well.
If you were just doing it here and you weren't doing it before.
Yeah, it's just that you have to do it once for sure. So before it is just a way to refactor. So instead of having all of these lines of code in every single test, I do it once up here, and I'm good to go. So yeah, the way things run in the end is that it's going to do before each, then this test, then before each, then this test, before each, the next test, and just do this for every single run. You can also have after each to reset the states if needed. Yeah, tear things down, basically. Any other questions? Yeah, so the as that you asked about, it creates a variable, an alias that you can use later that way, for instance. So another use case for it is if you have a button that you're going to use all the time in your test, just give it a name, and then you can do this dot my button dot should be visible, or should be clickable, or should display, that kind of thing. Just avoid repeating the selector for that element. Yeah, same idea here. My route to rate, I give it a name and then I wait for it. And that's what I had. Any other questions? Yep.
What if the element's not visible yet? Can you scroll down and do that?
So that's one of the things that you have to do fairly often. If you have a big application with lots of things on the screen, the CY contains or get is going to fail if the element you want to check is not visible. So sometimes you have to do Cypress, scroll down a little bit to make sure the element is visible. Yeah, in one project I worked on, I ended up doing my own command to just do a scroll into view to make sure you would scroll to that element and then check that all is right with it. Because otherwise my test would fail depending on the size of the screen I was running on it. So if my screen was tiny, the element would be hidden, the test would fail. If the screen was big enough, it was visible and it would pass. So to make things consistent, I would have to scroll up and down, make sure that that was not happening. The other thing you can do to avoid that kind of issue with Cypress, you can set the size of the viewport. So you can say it's 24 pixels by 768 or whatever you want. You can even test with different definitions to make sure that the responsive version of your app works as well. So there's also that option to say, hey, run with the following height and width. Yeah, they follow pretty much everything, which is really nice.